Jeremy, it's a pleasure to have you here. Thank you so much for getting the time to join us today. Jeremy has over 20 years of experience in software engineering, and this varies across various industries with a focus on distributed systems, e-commerce, and cloud-native technologies. So, Jeremy, I'd love you to just take this over, and all the best.
Well, first off, thank you to Andela and everyone affiliated for giving me the opportunity to speak today. I was very flattered, so really looking forward to this and seeing if I can just, impart a little bit of what I've learned over my career. So who am I? Why should you listen to me? I mean, I'm just another guy on a remote teleconference these days. So I've been doing it for a while. I've got 20 years of software experience. I got a bachelor's degree in computer science and an MBA from Ohio State University. And Ohio is in the Midwest, if you're not familiar with the geography of the United States. It kind of looks almost like a little bit of the boundaries make it look like a little heart. We're about 6 hours from Chicago, if that gives you any indication as to where we are. So, spent a lot of time working across a variety of industries. Spent a lot of time in the telecommunications space, which is pretty complex from a domain perspective. Some time in e-commerce, and most recently I've been in the financial industry. Across my experience, I've worked on very large distributed systems. I've done some cloud native development. Most recently, I've been working in mobile. So looking back, it's been good to have, a variety of experience across kind of domains as well as kind of tech stacks. I'll get it out. And every new experience gives you a different perspective, something else to learn from, and kind of gives you that more experience to take on to whatever you might do in your next project. So what is clean code? Most of the time I'd react the same way, like, well, I don't know, what is it? Like, who says? I mean, it could be anything, I don't know, like, and it is very subjective. Obviously, if you ask a lot of different people, they're probably going to give you a lot of different responses. So in this presentation, we're going to think about it this way. For me, I think, when I think about clean code, it's actually the code itself. When you're writing it, the readability, the naming conventions, the comments, how long a function is, does the function do what it's supposed to do? All of those those micro details when you're actually doing your job on a daily basis. And when you think about architecture, it's the bigger piece items, it's the macro, it's how you actually put things together, right? Your building blocks, and why you want to organize things certain ways. But that's how I think of it. But again, let's ask somebody who probably knows a lot more about this on that. And that's, if you're not familiar with Uncle Bob or Bob Martin, he's pretty much the man when it comes to clean code and clean architecture. He's written 2 books that I've linked there. And he's done a lot of different things over time, but he's obviously been a very, very strong advocate for clean code. And everyone pretty much, if you're going to ask somebody, they'll probably point to what Uncle Bob has to say. But he kind of does the same thing that I'm doing. He asks other people. And I pulled a couple quotes from the book and that I thought were poignant, that I remember, that kind of appeal to me and I feel are valuable. And this one's from Grady Booch, who was made a lot of different contributions in the OO spectrum. But what really stands out to me about is the words that he chooses to use here. And I think that's like the most important thing. And then Uncle Bob here also mentions Ward Cunningham, who was also one of the, I believe, I always get confused. I think he was one of the founders of extreme programming. So, and again, he's emphasizing similar things here. When you read code, you turns out to be what you expected, and that it just flows well. Just like in any of our native languages, we know when someone is writing or the diction that they're speaking with just is natural, so to speak. And I think that's what Ward is pointing out here. So, as I was alluding to, like both of those comments, I think the key kind of things that I want to emphasize and take away from them are when you talk about it, you're talking about intent, clarity, and simplicity. Does the code do what does the intent of what the programmer was trying to achieve clearly come out to you? Is it clear? Do you not have to sit there and scratch your head? And is it simple? Do you not have to sit and think about why somebody would do that? It was just plain to your eye. And I think both Grady and Ward are pointing that out in their quotes. And I think the biggest part of why I'm mentioning this from my perspective is we're not programming in isolation. We may sit here now, especially in a virtual environment because of the pandemic, and feel like we're isolated and separated from one another. But no matter what, you're going to be coding with your teammates, and you don't program by yourselves. You program as amongst the team, and it's a shared product. It's a collective product that you produce as a team. And you want, in my opinion, you want whatever you to produce something so that if I hand it off to another teammate, they can pick up and run with it. We don't want to just give them something that looks like spaghetti code and then have them go back. So it's kind of, to a certain degree, it's kind of about being respectful, in my opinion, because it is a shared word product. And I think to that end, Boy Scouts are kind of a group in the United States where young boys can go and learn kind of life skills and do service projects for the betterment of the community. But in general, the idea is that you should always try to improve the code whenever you're in it. You may be tasked with doing a certain type of ticket or story or what have you from a functional perspective. But while you're in there, even little things incrementally and improvements that you can make in the code base will go a long way in the long run. So let's kind of get into some of the details here in terms of what practices help you to produce clean code. So meaningful names, right? I'm sure we've all looked through code and you'll see variable names that are kind of vague or misleading. But most importantly, again, it comes to intent. Someone shouldn't have to guess what you were thinking or what you were trying to articulate with the variable name. It should be obvious. It really helps in this day and age if it can be searched from within an IDE easily, because we're using that on a daily basis. Easily pronounced, Now, that's obviously subjective, but depending on your working arrangements and what have you with the rest of the team, it should be pretty clear as to how you want to kind of proceed along those lines. And then domain and context aware. So what I mean by that is that you want it in such a way that I would not like prefix things with like the domain or something, if it's I'm trying to think of a concrete example right now. I typically try to, if I'm in the financial industry, there are different interest rates, for example, right? And interest rates have different meanings. I'm just making this up. But unless I need specificity as to what I'm talking about, I try to pick the most general name because I already know where generally the context that I'm operating in. So, it all depends on which domain you might be working on for a given project, but don't go overboard in articulating that this is an interest rate for an auto loan. I'm making it up, but if you already know you're dealing with a loan for autos, you don't need to re-articulate that it is for an auto loan. So that's what I'm trying to allude to there. So functions and methods. Number one thing, they should be small. I'm sure everyone's looked at some piece of source where they have like a 500 or if not worse, maybe 1,000-line function that somebody wrote. And you're like, how the heck does this thing work? So at the end of the day, small almost always beats large. And the more you can decrease the size of your functions will pay dividends in the long run. And in that end, it should do one thing. The minute you have a function that gets into the 500,000 line kind of spectrum, you're dealing with something that's doing more than one responsibility. And that in of itself is problematic. This is, one that probably is the one that's the most difficult to probably achieve in a lot of ways, but really taking a functional mindset or a functional programming mindset helps a lot to not only, these 3 bullet items that I've listed so far, they're consistent in reinforcing. So if you have a small function, then it's much easier to have only single responsibility, right? State outside of that function that you don't need to. And by doing so, you really start to get things that become, quite simple. And most importantly is you follow the drive principle or don't repeat yourself. You're not redoing effort or logic that you don't need to. Quickly on comments. So again, I think to carry on with the theme that I mentioned before, like intent, clarity, and simplicity rule the day here too. There isn't, you shouldn't be scratching your head when you read a comment. It should be clear. But that being said, comments aren't meant to like absolve bad code. They're not meant as a way of, oh, I'll explain why I did something that didn't make sense. No, that's not what a comment is for. And in general, less comments are better than more comments, because the minute you start having to comment your code significantly probably means you're going away from clean code to begin with, because the intent, clarity, and simplicity of what you're writing isn't there. it's not apparent to people or other programmers. Comments, in my mind, should be there when you're doing something that's not as intuitive as you might expect. And maybe you made a change for valid reasons related to performance, where you want to kind of just make a particular algorithm a little bit faster. That is certainly a valid reason to write a comment. But if there's a general rule of thumb, let the code speak for itself. Focus on writing code that's as simple, as clear as possible, and don't burden it with a lot of comments unless there's something that isn't necessarily intuitive to the group as a whole, or to another programmer, excuse me. Just quickly, code style, again, it doesn't so matter. Again, everyone's going to have an opinion on it. I've found in the teams that I've worked with or I've worked on, I don't really get too strongly opinionated one way or another, but I do prefer to have one style and everyone to stick with it, because it's just like if you were to open a book. You don't want to read a book with pages that are inconsistently indented and have margins that vary from page to page. It just detracts from reading the book, the same way with reading code. So my advice is always, whatever team you might be working on, come to some agreement as to what style you want to follow, and then use that style and the IDE that whatever you're going to use, and distribute it to the team so that everyone can consistently use it. So classes, just like functions, they should be small. Always prefer many small classes over a bunch of God objects. And the same idea here, no difference. Like, do one thing. And most importantly, it's not only doing one thing, and we'll talk on this later as well, it's having only one reason to change. So if in the future your requirements change, ideally your class should only change for one reason related to that requirement. It shouldn't, so it's a tough thing to kind of grasp maybe initially, but really segregating what a class is supposed to do, the functionality, and making sure it does only one thing, and then if tomorrow, whatever that thing may be, changes, you only have one reason to change. This is something that I use. Your mileage may vary, but if I'm going to describe a class that I'm writing or trying to design, I usually just try to describe it in one sentence. If at any time I use and or some other conjunction, usually sign to me that I'm probably doing too much within it and that it's not following a single responsibility. And then I kind of have to come back and say, okay, what is it that I'm trying to achieve? Do I need to refactor and break this apart into another piece? So you'll hear a lot of people talk about this, coupling and cohesion. Coupling is kind of what it sounds like, how tightly something is interconnected with something else. And cohesion is along the lines of, how close to what the intent of something is and how everything works together. So when we're talking about classes and systems as a whole, you want things to be as loosely coupled as possible, obviously, because you don't want to depend on things. The minute you start coupling things together, you end up having to change a bunch of different things. And you want smaller, highly cohesive pieces of classes and components so that they work together in a consistent way. You'll hear this said a lot of times, and I refer to it a couple of different places too, that depend on things that change the least. So rather than programming to an implementation, you want to program to an abstraction or a type, so that the idea is obvious, if you're familiar with the dependency injection, inversion, etc., that you are programming to a contract. And in the future, if someone wants to change how that contract is implemented, it will not affect the code that you have written. In fact, they should be able to swap that out without your knowledge, and your code should still work as intended. So this is one way in which you can achieve low coupling. So testing. We really haven't talked about the distinction between new and legacy code, right? I'm kind of assuming that we're kind of all writing maybe new code here thus far, but in the reality that never happens, and most of the time that we do our jobs, we're going to spend just coding with legacy code for that matter. So, and it comes back to well, how can I write clean code if I've got all this legacy spaghetti code and stuff? It's tough. There's no easy way around it. But again, if you follow the Boy Scout rule and incrementally, on the margin, try to make small changes here and there, over time, you can transform bad code into clean code. But at the end of the day, the only sure way to transform any code for that matter, and to have comfort in what you've done, to make sure that you haven't broken anything, is to have unit tests or integration tests that verify the behavior and the invariance of the code that you're working on. It's the only way to do it. And by doing that, then you can, it becomes simpler, but you can take, I can make one small change and make the code better. And then I can make another small change on top of that. And I can always just keep running my tests while I constantly improve the code. And this is critical. Otherwise, you'll be fighting a constant battle. Whether did I break something? Did something working, or was it not working before? So we're going to transition here into clean architecture. And again, we've talked about the low-level constructs, the micro things. So when we talk about clean architecture, let's talk about, again, the macro. How do we build things? How do we put those lower level blocks together in a consistent, reinforcing way for the whole system? And whenever you're building, and architecture here maybe is a little vague, but when you're building a system or an architecture, at the end of the day, it has to support the functionality and whatever the operation of the system you're working on, whatever it may be. That's number one. You have to also think about, how are we going to maintain it? How over the course of our time, how is this system going to be maintained? What is it going to cost to maintain? What is it going to cost to obviously develop the system, to actually write the code to make it work? And then what does it take to actually put that system into place? In the mobile architecture, it's maybe not, it depends. I mean, there are multiple facets. So you have, the client side in terms of a device, but then you also have the server side. So server-side deployment considerations might be much more involved than obviously on a device. So another quote from Grady, and the reason I threw this one is, what I think, and he says architecture represents the significant design systems that decisions, that shape a system, where significant is measured by the cost of change. And that is, I think, the cost of change is the clear caveat here that he's alluding to. When we do our jobs, you'll be dealing with project managers, you'll be dealing with people from the business side of any organization that you might be working. They're, and rightfully so, they're going to be focused on getting those requirements out to your consumers or whoever your stakeholders may be. But never lose sight of the fact that as software developers and architects, our job is to kind of always ensure that while the business, your product people are focused on those functional requirements, ours are making sure that the system as a whole works. So not so much just the focus on behavior that you're going to get from one side of the organization that you're working on, but our job is to maintain that structure of the system and to do it in such a way that overall, over the lifetime of whatever you might be building and maintaining, you minimize the cost. And I think I can't emphasize this enough. I think this is something, and it's tough in the business world when you're always getting pushed and pressured to deliver those functional requirements to meet a date or something. But at the end of the day, this is really what software architecture and clean architecture is about. How do you build something that not only meets those functional requirements, but you build it in a way that over the long run, it's extensible, it's easy to maintain, you can easily deploy it, and if you have to change it in the future, it's going to only require a minimum amount of effort. So that's where we get in, and that's the reason that there is a kind of field of clean architecture and architecture as a whole. Now, there are lots of things. I'm just going to talk about those things, those high-level concepts that I think are important. So maybe many of you have heard of SOLID. It's an acronym for 5 separate OO design principles. And I like this quote from Uncle Bob, and this was kind of what I was alluding to earlier, is we've talked about how to build the bricks and the features of a wall. Now we're talking about how to arrange them in the right way so that you form walls and rooms. So again, now we're kind of moving into the macro space. And what I think is always key is remember that, like a lot of things in life, composition plays a big role in how things are structured and organized, and good software is no exception. So we've already talked about it, when we talked about functions and classes. Same idea here again, single responsibility principle, change for only one reason. I won't go too much in. Open and close principle, when you're designing classes, you typically want to avoid what's called, sometimes often referred to as the fragile base class problem, where you may be subclassing an abstract base class and the base class implementation changes without your knowledge, and of course it may break your subclass implementation. So the open close principle states that classes are open for extension but not for modification. So that's where that comes in. The Liskov substitution principle is a fancy way of saying, like, when you're dealing with subtypes in collections or something, that your subtype should be easily substitutable for its parent without altering the correctness of the program. This is kind of along the same lines as the last one here. I'll jump quickly to that. Interface segregation principle is what it sounds like. You want your interfaces to be as small as possible. And then dependency inversion principle depend on only abstractions. Again, if you depend only on abstractions, you kind of reduce the coupling, you treat everything in a more closer to a polymorphic way. So components kind of our next higher level of composition when we're talking about clean architecture. But you can think of it like a jar, a DLL, an assembly, and .NET, those kind of units of deployment that you might have. And when we're talking about components as a whole, now we're talking about once we've got our bricks arranged into walls and rooms, now we're talking about arranging rooms into buildings, is what Uncle Bob is alluding to. And again, this is kind of along the same lines, again, as the single responsibility principle. Now that we've got kind of our building blocks together, now we want to arrange those building blocks together that operate together and operate on kind of the same interval. And so it's another way, maybe at a more of a macro level, of thinking about how do you group those things that have the same purpose or work together in the same way for the same end in such a fashion so that you isolate those things together. This one probably is pretty obvious, but it's just basically, you know, it kind of dovetails a little bit with some of the things that we just alluded to, like in the interface segregation principle, and that you obviously do not want to depend on things that you don't use. There's no reason to have that coupling, that ability to, you know, disconnect from things that aren't relative to the purpose that you're trying to do from a component perspective. Obviously makes your component less coupled, and it makes it more focused on what it's actually supposed to do. This one is should be pretty clear that when you're dealing with dependencies between components, you want to avoid dependency cycles at all costs, because that is just a killer. Then you have coupling to the extreme. And then obviously you want to, again, reiterate over and over again, depend on abstractions, depend on the protocols, the contracts between the components rather than the implementations to, again, loosely couple everything. So when you're going through all of the decision-making process, you have to kind of, when I think about things, I try to like assess and independently the different dimensions that might be involved in what I'm trying to produce. So that could be development, deployment, operation, like I alluded to earlier. And there's no set in stone way to think about it. It's definitely more art than science, and over time you kind of develop a feel for it. But at the end of the day, it's understanding what are the most important decisions that you need to make right now and which ones aren't essential. And if they aren't essential, delaying those so that you can focus on the most immediate problems at this time, and then move on to those things that maybe are less important to what you're trying to achieve at this moment. But always keep in mind, again, have to support the use cases of the system that you're designing. So there is, you know, and I've gone over in 25 minutes or so everything, and it, you know, it just takes time and practice. I won't say that I'm even an expert. I learn something new every day. I get a different view, a different take on things. So you just have to learn by doing when it comes to all these things. And for me, it's always been you have a plethora of options. How do you balance those options against what you have to produce, what the requirements are? There's multiple different ways to solve a problem. There's never going to be a perfect solution. There always will be trade-offs. But the principles that we've talked about, the practices that we've just gone over very quickly, will help you to think about, if you follow them, that will help ease that burden in terms of balancing those options. Because it will already put you on the right path, in the right direction of producing an architecture or a system that is going to be extensible. And you'll get a feel for it, like over time, what's important now versus what can be delayed. And as I alluded to a few minutes ago, again, always be vocal as a software architect or developer in terms of being that advocate for the structure of the system. Saying why we need to take a little bit longer, maybe to put something together, because in the long run, it's going to reap benefits in terms of minimizing the cost of effort, versus if I produce something very, very quickly in the short term, but tomorrow I won't be able to maintain it, and it's going to cost too much to fix. That's the most critical piece that I think I can leave with you, that, you know, you always have to be vocal about it. And it's not about being a naysayer or saying that you can't do something, but it's about providing the information to those decision makers, whether it be in the business or the organization that you're working for, so they understand the true costs of what it really requires to build a system that's functioning and will be able to be maintained and updated in the future. Okay, so those are the slides. Let me jump to, everyone can still see my screen, correct?
Yeah, we can see your presentation.
So what I just came up with here is a simple Kotlin scratch file. And this is a very contrived example, but I thought it would be maybe a good way to concretely articulate how, you know, we can show some clean code. So
sorry, Jeremy, I think we still see your presentation. Were you meant to bring up your ID?
okay, let me, yeah, my bad. You can either be exempt or non-exempt, and in the US that basically means you're either eligible for overtime or you're not eligible for overtime if you work more than, say, depends on the state, but either 40, 45 hours a week. And then the salary unit is something else. So then I wrote just like two simple functions here that take in a list of employees, and one returns the list of those list of employees, returns if there are any basically employees that are part-time, and the other one produces the employees that are full-time. And so then what I did is I just wrote a couple stub methods here so that to kind of lay out a foundation for you to kind of think about, all right, given that, how do I write kind of a better way of finding the part-time and the full-time employees? So, and there's some sample data here that I just set up in the worksheet for like a different list of employees in terms of, we've got Nancy, we've got Debbie, excuse me, Alexander, Winston, and Phil. all you need to know basically here is that so if you can see, if you're not familiar already with like scratch sheets and in in Android Studio, it'll kind of, it's a little bit of a REPL kind of interface, like when and it will evaluate as you type in there. And all I did here is I kind of had my original solution here where I say, is Debbie a part-time employee? Yes, she is. Is Alexander? Yes, because if you go up here and you'll see what I populated, Alexander, Debbie are both part-time. Nancy, Winston, and Phil are full-time. So then Phil, of course, is not. So it says false. And then the opposite, I did the same thing for full-time. Debbie and Alexander are false, and Phil is true. These don't evaluate because I put a to-do implementation here, if you're familiar with Kotlin. So those are basically the stub methods that I kind of laid out in terms of provide for you to kind of provide a more cleaner code implementation. So you should be able to take the file that Mercy, the link out that's on GitHub, and if you have issues, what you can do is if you open Android Studio, or it should work in IntelliJ, I'm not for certain, and you say file, new scratch file, and then you say Kotlin. If you copy and paste the text that's in that file, it should go in here and then it will evaluate just the same way as what you see over here. And then once you have that, you should be able to, within the editor, feel free to make changes as needed. So I kind of opinionatedly pushed you down maybe one route in terms of how it could be implemented. But there might actually be that I did this initially, I thought about it, there might be actually one potentially even simpler way of going about this, if you're interested. It might be actually less code. Now, the solution I'm thinking about here too would maybe less readable. So this kind of a point out there. Did we want to give everyone a few minutes to play around with things, or do we want to jump into solution and answer questions?
I think we can jump to the solution, just so we can still keep time.
All right. So I'll share this as Mercy alluded to. So what I did is, instead of I just left the original kind of two method functions here that they were, and then I just wrote a new function called find employees. And if you're not familiar with Kotlin or in-depth syntax, I mean, it can be solved obviously, cross languages in a similar way. But all I did is I wrote kind of a higher order function here. So, and if you're familiar with function, is any function that returns a function or takes a function as an argument. In this case, what I did is I created a predicate. And if I jump back a little bit, if you notice, this was a contrived example. The code was almost all identical. You're just iterating over the list of employees and then finding out whether they're full or part-time and then adding to the list. They might have, the iterations were slightly different, but they were basically doing the same thing. And I just abstracted that out into a higher order function, which all it does Now that it takes a predicate with saying, give an employee, return a Boolean, I'm just filtering out that list that gets passed in and returning it. So now I have a find employee. These two optimized methods just call find employees with the list of employees. The only difference is here is your function type or your closure, where I say, okay, I've got an employment in the case of, or employee, excuse me. In the case of part-time, I just want to check again this condition, this predicate, are they part-time? And if they are, I'll filter them and produce them into the output set. And now, in the case of full-time, I've just changed the condition a little bit here. So now I've got one higher order function that is just responsible for taking the list and filtering it. And then I have two functions that are just relying on that. And the only difference is they're changing the condition on which they pass through, or the function type. So we went from, potentially like duplicated code that was repeated in iterations and lots of logic that wasn't there, and we're relying on the internals that's already provided out of the box in the language just to filter the list as appropriate and get it done. And so then if you see down at the bottom here, I had two more, basically the same checks with just the different methods, and they match up, right? True, true, false, 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 true, just like the first one. So there are probably other ways, again, without getting too deep in the details, there's details in terms of like, there's a partition function which you can use in Kotlin, which would actually, if you meet the condition, it will put it into one set versus everything else that doesn't meet it, puts it into another set. So that could be actually a little less code. That's what I was alluding to earlier, but it may be not as readable. So.
So thank you all for joining. This has been amazing. It's been a pleasure having you all. Jeremy, thanks for the time. And we hope to see you next time. Keep safe and, God bless. But if you have any questions, continue engaging with us online. All right.
Thank you very much. I enjoyed it.
Thank you, everyone. Be safe.